within the newspapers, which escalated in the university. It was very bad.
Now, even Professor Fleischmann acknowledges he made a mistake.
It isn't fusion. It's not fusion in the narrow sense. It is not fusion. Charlatans, frauds, yes. Well, they'll say whatever they want to say.
Professor Fleischmann continued his work for a few years. But ever since March the 23rd, 1989, he has found it hard to get papers published in scientific journals.
So you just squeezed out. Extruded. Scientifically extruded. Well, never mind.
It seemed that the dream of a shortcut to nuclear fusion was dead. But then something happened to resurrect the dream. It began when physicist Seth Putterman heard about something that seemed more like magic than science. It was a way of turning sound into light. Seth Putterman was so intrigued by this idea that he set about trying to do it himself. It's a process called sonoluminescence.
The first time I saw sonoluminescence was in a darkened room. I was transfixed to look at this spherical flask of fluid, and you'd look into the center, and in the center see a glowing blue-purple light, which could be seen with the unaided eye. It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light, several thousand times a second, giving the appearance of a star. What made the phenomenon so exciting was the temperature of this star in a jar. On its surface alone, the light burns at tens of thousands of degrees. And Seth Putterman now contemplated a tantalizing possibility. Could the core of the collapsing bubble be even hotter? Hot enough for fusion?
One of the mysteries of sonoluminescence is to determine exactly how hot the interior of the bubble gets. In the sun, the interior can be millions of degrees, hot enough to cause fusion. And the thought crossed my mind that perhaps inside the collapsing bubble, the interior of the bubble might also get hot enough to cause fusion.
If so, this would be something truly amazing. By simply bombarding tiny bubbles with sound waves, temperatures of over 10 million degrees would be created. And nuclear fusion, the same reaction that powers the sun, would be happening almost effortlessly here on Earth. One organization realized just what was at stake: the US government. They immediately started pouring money into research to investigate whether sonoluminescence could finally be the shortcut to nuclear fusion that scientists had been dreaming of. And across the USA, several groups set to work trying to achieve this remarkable goal. One of those groups, based at Oak Ridge National Laboratory, was led by Russi Taliarkin.
Late January 2001, late afternoon. Trying to look for signals. Now started pressing the button on our high-speed scope and just kept our fingers crossed and said, let's see what comes out. The very first time around, it started clicking. That was extremely exciting.
The clicking was the sound of a detector recording neutrons, the telltale sign of nuclear fusion. At the first attempt, it seemed that Russi Taliarkin had done what nobody else had been able to do: make his star in a jar hot enough for nuclear fusion. The key to his triumph was a brilliant idea. In sonoluminescence, vapor molecules trapped inside the bubble smash together, heat up, and give off a flash of light. But Russi Taliarkin realized that too many molecules might actually cushion the bubble's collapse, and so the reaction wouldn't be violent enough for fusion. So he started with smaller bubbles that contained fewer vapor molecules, which he thought would now be forced together with much more energy when the bubble collapsed, creating a much hotter core inside his star in a jar, a core that would finally be hot enough for fusion. And in January 2001, it worked, and he detected neutrons.
Elated is not the right word. Ecstatic may not be the right word either. I mean, it was difficult to sleep soundly at night that day onwards.
Russi Taliarkin knew that his breakthrough would be big news. But he also knew that cold fusion had been big news before it was comprehensively discredited. So over the next few months, he checked his results and confirmed them with other tests. He measured the neutrons again and again, but the results were always the same. And only then was he convinced about the scale of his discovery.
Nuclear fusion is a major finding. Some people think that it may be worthy of a Nobel Prize. It would be nice if it were, but I don't keep dreaming about it. If it happens, so be it.
And so the dream of a shortcut to nuclear fusion and the prospect of unlimited clean energy was alive again. But that was just the beginning of the story. For such a huge breakthrough to be scientifically accepted, the results first had to be published. Russi Taliarkin aimed high and sent his paper to one of the most prestigious scientific journals in the world. Science magazine. Its editor, Don Kennedy, remembered just what had happened with cold fusion.
With the overhang of cold fusion, one would naturally be a little hesitant about a fusion claim that looks improbable. But you shouldn't ignore something because it's scary. I think the experiments were very well done. I found them convincing. And so